To find the angle between the two vectors, from the definition of the dot product, we have the magnitude of A times the magnitude of B times the cosine of the angle between them, which we can convert into the cosine of the angle is the dot product divided by the product of their magnitudes. And so that's how we'll find the angle theta between the two vectors. So here's vector A. That's pretty straightforward. But vector B is V plus W, so we got to add these two vectors. I prefer to do vectors in component form because, as you can see here with the W vector, there's not a middle component, and that gets a little confusing when you're adding those. Vector V then is a -2, -3, 2, and vector W is a 1, 0, 2. So when we add those, we get vector B is -2 plus 1, -3 plus 0, and 2 plus 2. So then, the dot product of A and B would be 3 times -1. I'll go ahead and multiply these out. And -1 times -3. And -2 times 4. The magnitude of A would be 9 plus 1 plus 4, and the magnitude of B, 1, 9, and 16. So this comes out to be, in the top, a -8, and in the bottom, this is the square root of 14. This is the square root of 26. You have to work this out on your calculator, which comes out to be 2 square root 91. And we can simplify this to be a -4 over square root of 91. So if the cosine of theta is equal to -4 over square root of 91, we know that theta is the arc cosine of that. Alright, so we'll try our calculator, see what we get. Now our answer needs to be in radians, and you see here that we are in the radian mode on our calculator, so what we type will produce an answer in radians. And here is the arc cosine, -4, and the square root of 91. And we'll use the green equals to get the approximation. So to 2 decimal places, that would be a 2. We're trying to find all of the three-dimensional vectors that are orthogonal to this vector. What we'll do is we'll just dream us up a generic three-dimensional vector. So we'll start just by assuming that the vector we're looking for is going to be some components A, B, and C. Now we're told that that vector is orthogonal to this one. Now that simply means that the dot product of those has to be a 0. So we'll take the A, B, C that we dreamed up, the 1, 1, 0 that we're given, and do their dot product. the dot product would be A plus B plus 0, and that has to be a 0, which means if we move the B over, A has to be equal to a negative B. So we can use any values as long as the second component is the negative of the first component, or vice versa. And the third component, since it's not even in the picture, can be anything whatsoever, which means our vector is going to look something like this. We can have an A for this component and a negative of A for this component, and anything whatsoever for this component. Now, on this group of problems, we're first off trying to find the direction cosines. So the cosine of alpha and the cosine of beta and the cosine of gamma are what we're looking for. And it's just a matter of knowing the formula. Look it up in your notes. We need the magnitude of the vector. Negative 1 squared is 1, 5 squared is 25, and 2 squared is 4. So that comes out to be a square root of 30. That doesn't simplify, so we'll just leave it like that. And so we take the first component, negative 1, divide by the magnitude, and there's our direction cosine for alpha. We take the second component, divide by the magnitude, and the third component, and divide by the magnitude. So there's the first half of the problem. And then the second half is to find the direction angles. The direction angles are nothing more than the arc cosine of those numbers. So alpha is going to be the arc cosine of the negative 1 over square root of 30. Same thing for the beta and the gamma. I won't write all those down. You can see what they're going to be. Now the kicker is two different things. Number one, we're asked to round off our answers. That sort of implies that it's not going to be nice exact values. So obviously we're going to need a calculator for doing this. And as you could probably tell, if I ask you what is the angle that has a cosine of negative 1 over square root of 30, that is not in the list of things that we normally use. Also, we're asked to do this in degrees. So let me show you on the calculator. Here's what we want to do. I want to put my calculator in degree mode. Right here it says radians. To put it in degree mode, I go to the mode button, go down to where it says angle, put the right arrow, select degree, and enter to save it. So now whatever calculations I do come out in degrees. After putting it in degree mode, we simply type the arc cosine of negative 1 over square root of 30. Now we've done this earlier. To get it to round, we use the green enter key. And that's our approximation key. So to the nearest degree, that would be 101. Here I'll just scroll in my input bar, erase the negative 1, change it to a 5, and use the green equals again. And that's approximately a 24. We'll change the 5 to a 2 and use the green equals again. 69. Now I know I'm a little old-fashioned with this, but again, I prefer these in component form. This one is a 302. This one is a 024. So there's the U and the V. We're first off in the A part finding the projection of V onto U. V onto U. What that means is the projection of V onto U is going to be some component times U. U is the vector we're projecting onto. We're trying to find some multiple of U. Now that sort of sets the stage for the rest of the formula. As you recall, the formula is the dot product of those two vectors over the magnitude squared of the same vector here. That's kind of how you remember your formula. And so anyway, now it's just a matter of doing those calculations. Some of these I'm going to do kind of quickly because I'm sort of running low on time on my video. So the dot product of U and V, 3 times 0 plus 0 times 2 plus 2 times 4, comes out to be an 8. And the magnitude of U is the square root of 9 plus 4, which is 13, squared, which would just be 13. And so that is what I've got in the box, and that's times the vector 302. So that comes out to be 3 times 8 is 24/13, 0 and 16/13. So there's the projection of V onto U. Now you can do this any number of ways. The B choice, the component of V in the U direction, is nothing more than the magnitude of the vector we just found, which, by the way, happens to be this, U dot V over the magnitude of U, because the rest of this, the other magnitude of U, gives us the unit vector in the U direction. So we could do that calculation, which is also the component of V in the U direction. But since we've already done this projection of V onto U, we can just do the magnitude of that. So the magnitude of that is going to be the square root of 24/13 squared plus 16/13 squared. And so we can do that on our calculator. I won't take the time to do that manually and make you watch me do that. And that comes out to be 8 over square root of 13, or we sometimes write that as 8 square root of 13 over 13, rationalizing the denominator.